Dilations. This is the fourth transformation that we're going to talk about. And all the other one were rigid motions, meaning when I translated, when I rotated, when I reflected, the shape didn't change size or scale. But with a dilation, that means specifically that we're making it bigger or smaller. So a dilation is an enlargement or reduction. And we do it around a fixed point. So that's called the center of dilation. We're going to use the origin. It can be other points as well, but we're going to use the origin. A dilation is an example of a non-rigid motion. That means that it's going to change. Rigid means stiff. Non-rigid means malleable or changeable. It does not preserve congruency. That means that our shapes are no longer congruent. With all the other ones, the angles and the sides were the same size. This one will not be. A dilation produces similar figures. Again, that means that they are proportional, not congruent. So one might be twice as big or 1/3 as big as the other one. So there's a direct relationship between all the sides, but they are not congruent. We call that change, like whatever we're going to use to change our figure, our scale factor. That's how much we will enlarge or reduce. So scale factor is how much. We use the variable lowercase k. So when I gave you the rule yesterday, it was kx and ky because we're multiplying that times it. So when k is greater than 1, that's an enlargement. And when k is less than 1, that's a reduction. Now, why do we care what the number makes it? Because that's one of the ways that you can check that you're doing it right. If you graph something and you know it's supposed to be bigger, and it's not, then you've made a mistake someplace. So these different pieces are checks and balances. It's how you can look at your work and be comfortable in your answer, because I was graphing an enlargement and lo and behold, my image is now bigger than my pre-image. Or it went from a square to a triangle. I probably made a mistake someplace. I can change size, but I'm not supposed to change shapes. So the dilation rule, here's the big words that says everything we gave in the rule yesterday. If the point P, which is given as xy, of the pre-image, that's our original drawing. Then the image, that's the after. When it's centered at the origin, and we're only going to focus on those with a scale factor of k, then we take xy and we multiply k by both coordinates. Now don't forget, there's an imaginary or invisible, not imaginary, there's an invisible multiplication between the k and the x and the k and the y. Kx means k times x. Ky means k times y. So all we're going to do is take whatever original coordinates were given and multiply both pieces by k. That's it. So on your card, you have a list of all of the rules, including the dilation. That's what I want you to be able to do is go, okay, it says dilate. Where's that on the card? What do? I multiply both things by my scale factor. What's my scale factor? So we're going to read the instructions, graph and label each figure and its image, that means after, given the scale factor. Assume all dilations use the origin as the center of dilation. So that's important. We're only using the origin, but in later objectives, you might use a different spot as your origin. As your center of dilation. So I'm going to zoom in as big as I can, and then you can copy this stuff down on the side. So, first of all, I have a triangle. That means I need to have 3 points and 3 sides. When I'm done, I should have 3 points and 3 sides. Here is my scale factor. On practices, assessments, it will either say the scale factor is 2 or it will say K is 2. You need to know that those two things are interchangeable. So we're going to graph what we have first. -5, 1. There's R. -3. There's S. And 2, -1. There's T. So here's my pre-image. This is where we started, right? So there's my pre-image. Now, for R prime, S prime, and T prime, my rule is that I go from XY to KX, KY. So this is 2 times -5, 2 times 1. 2 times -5 is -10, and 2 times 1 is 2. That's my new point. So all I've done is just added K in front of, here's my original point, there's -5 and 1. All I did was just multiply that. Now, because I have a scale factor that's bigger than 1, right? So I know that this is an enlargement. I know that I'm making this bigger. So when I'm done, my new triangle should be larger than the one that I have. So 2 times -3, 2 times 4, that's -6, 8. And then 2 times 2, 2 times -1, that's 4, -2. Those are my new coordinates, and all this 2 is our, what are you doing? What do you need? Nothing?
Gonna go?
No, go away. Cuss.
Later?
Maybe. So all this is where we multiplied each coordinate by 2. So we graph our new coordinates. -10, 2, that's R prime. -6, 8, there's S prime. Now, for everything else, we could have counted lots of other things that we've translated and shifted. But I can't count here, especially because this is a diagonal line. I can't make sure that there's not an easy way to do this except to multiply by K. And then 4, -2, there's T prime. And so when I connect my dots, there is my image. Once you know what the rule is, it's just about applying it. We're going to take this scale factor K and multiply it times everything that's there. Please make sure that your phones are put away. All right, let's look at number 3. So this time I have a fraction. Not only is it a fraction, but is half greater or less than 1? Half is less than 1. That means this is a reduction. I'm going to reduce this shape. And it's a rhombus, which means I have 4 sides. So we're going to graph it first. Negative 10, 2. That's J. Negative 2, 8. K. 6. 2. That's L. And negative 2, negative 4. That's M. Okay. So there's my original image. Now, when I find all my points, when I do J prime, K prime, L prime, and M prime, it's half times negative 10. Half times 2. Half of negative 10 is negative 5, and half of 2 is 1. Half of negative 2, half of 8, that's negative 1, 4. Half of 6, half of 2, that's 3, 1. Half of negative 2, half of negative 4, that's negative 1, negative 2. So again, all that I've done is multiplied half times each of the coordinates. So 10, 2, there's my negative 10 and my 2. And you can use the calculator, or you can know that it's half and then substitute it in. So negative 5, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1. There's J prime. And negative 1, 4, that's K prime. 3, 1, L prime. And negative 1, negative 2, M prime. That's it. That's all you have to do. It's following along as we scale. Now notice that this is not in the center. It's not in the center of this diagram. So don't get mistaken that when you enlarge or shrink something that you have to put it in the center. One more, Natalie, and then you can. And when I'm done, one more. All right. So this is where this helps you, because what is 5 over 2? Is that bigger than 1 or less than 1? What's 5 divided by 2? 5 divided by 2 is 2.5. Is that greater than 1 or less than 1? That's greater than 1, which means this is an enlargement. Not all fractions are less than 1. So we're going to graph our original square. So we have 0, 0. We have 2, 4. That's E. 6, 2. That's F. And 4, negative 2. That's G. So there's my original shape. There's my pre-image. Now to find D prime, E prime, F prime, and G prime, we take 2 over 5 times 0. 2 over 5 times 0. And even though anything times 0 is 0, I'm still going to write it down because I don't want to make any mistakes. 2 over 5 times 2. Sorry, it's 5 over 2. Somebody stop me. 5 over 2. 5 over 2. 5 over 2. 5 over 2. And then 5 over 2 times 4. 5 over 2 times 6. 5 over 2 times 2. 5 over 2 times 4. 5 over 2 times negative 2. So in the calculator, you just put 5 over 2 parentheses 2. But you can also do this. What's 5 times 2? 10 divided by 2? What? 10 divided by 2? 10 to 5. And then I can say 5 times 4 is 20, divided by 2 is 10. Now that's a really big point. We haven't had anything that big, but remember, because you know that this is an enlargement, it's okay when my numbers start to get large. So 5 times 6 is 30, divided by 2, that's 15. 5 times 2 is 10, divided by 2 is 5. Again, that's a big number, but because I know I'm enlarging it, it doesn't seem wrong. 5 times 4 is 20, divided by 2, that's 10. 5 times negative 2 is negative 10, divided by 2 is negative 5. So when we graph our points, D prime is also at the origin. So you just put another dot and label it as D prime. Over 5, 2, 3, 4, 5, up 10 is E prime. Over 15, up 5 is F prime. And over 10, down 5 is G prime. So that when I connect all my sides, I can see that that's an enlargement of 5 over 2. So 2.5 times is big. So don't let the fractions, you have calculators that'll do that for you, don't let the fractions scare you. Use the calculator on the home page, and just remember that all that we did for each one of these was to add the fraction to each coordinate and then multiply to get our answers. So you put this piece in the calculator to get this answer. So finish with the different practices. This 11 through 12 are just points, and it tells you the scale factors. So that means that K equals 2, and you just get your new coordinates by multiplying by 2.